Hey guys, welcome back to another session of solving quadratics. Doing great here. This is just another method that we can use. It's called the quadratic formula. It's famous, infamous, however you want to think about it. It works, it's effective, it works in every situation. The calculations are a little bit much, but nonetheless, it's effective, okay? And since there are so many calculations, errors are made, and it might not be the best situation, depending on what you're given, okay? So right now, we know that there are three ways to solve quadratic equations. The first way that we work through them is by factoring. Okay, now factoring is good if you remember all the factoring techniques, which you should. We have the master factor plan that we can always rely on, and the question is, when can that be used? Well, it can only be used when the polynomial is factorable, when the quadratic, and we'll just keep it sweet, when it's factorable. Okay, if it's not factorable and you can't use one of those techniques that we talked about, in other words, it's prime, then you have to try a different method. Okay, the second method we talked about was the square root method, using the square root property. Okay. And we talked about when that might be used. That's only going to be effective if we have a square term. So when you have a square term, okay? In other words, you're missing the bx term. The bx term is the term that has x next to it. Okay, the third method, this was the last method we learned, is completing the square. And completing the square is really a combination of these two. We create a PST that we can factor, and then we take the square root of both sides. And when can that be used? That can be used all the time. Okay, now we haven't really seen this because we are being homeschooled right now, and obviously we're not able to go in depth and do everything that we would do at if you were in school, but you would see that even though it can be used all the time, sometimes the calculations are really difficult. Okay, and it can become a little bit cumbersome in order to figure out the solution. All right, that brings us to the quadratic formula. The quadratic formula is a formula that we can use for quadratics. So we're really going to end up with four ways, guys. We're going to end up with factoring, square root method, completing the square, and then also the quadratic formula. Okay, and that's what we're going to be going over today. So you're going to see here this works all the time. This is very good, just like completing the square. You got to remember the formula. It's going to look crazy. I'm going to warn you. It begins with x equals, okay? Because that is what we're trying to find. We're solving, so we're trying to find x. So it always starts with x equals. And what we're going to do, as we know, this is a quadratic. It's in the form ax squared plus bx plus c. We're going to use the coefficients in the formula to help us figure out what x is. So what's the formula? The opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. And that's going to give us two solutions. We're going to end up with a positive and negative root, which is going to give you the two solutions that we're looking for here. Okay, so we're going to do some examples. All of these look a little bit different. Please watch the whole video so you know what's going on, okay? Don't look at one. We never do one example because they're never all the same, okay? Or hardly ever, I should say. I try to keep them different so you can get some different feels. So the first thing we want to do is this equation, as usual, since it's a quadratic, we want it equal to 0. All right, so those two things are in place. They're good. We can identify our A value, which is 1, our B value, which is -4, and our C value, which is -8. We're now going to plug it into the formula up above that we just mentioned. All right, so I have X equals the opposite of B. Well, if B is -4, the opposite of B would be +4, plus or minus the square root. B squared, so -4 squared. -4 times -4 is 16. And then I substitute my A and my C into the formula. So it's -4 times A times C all over 2 times A. And 2 times A, 2 times 1 is 2. So now we're going to clean this guy up. I'm going inside the house to do some work. So I have X equals 4 plus or minus the square root. Now when we go inside the house, I'm going to clean up this part first because we know order of operations tells us to do multiplication first. And when I look at this 4, I know there's a subtraction sign there though. I'm going to think of this as a -4. So I'm going to first write down the 16, and now I'm going to take -4, multiply it by 1, which is -4, multiply it by -8, it gives me a +32. And I'm going to keep all that over 2. And that is where most of the mistakes are made. They're made inside this radical, under the radical, and we just got to be careful. And we're going to do a couple more, but they'll be a little bit different, but similar. Okay, so I got X equals 4 plus or minus the square root of 48 all over 2. Now we're getting close. As you guys learned and know, 48, the square root of 48 is not a perfect square. But we can break it down. We can think of 48. We're thinking of 48 as equal to 16 times 3. Okay, and the reason why is because 16 is a perfect square and I could take out a 4. So what we could do is we could take a 4 out and 3 would still be left. And this is what we mentioned before when we were dealing with radicals. Since all 3 of these numbers have a common factor of 2, I can divide all those numbers by 2. 2 goes into 2 once, 2 goes into 4 2 times. And my final answer is X equals 2 plus or minus 2 root 3. Okay, so that's what we're looking at here. We get our 2 solutions completely simplified, and let's keep rocking and rolling. All right, hopefully when you look at this, you notice, hey, this guy is not equal to 0. So the first thing we want to do is we want to add 2. You can't start solving this until it's equal to 0 and until you identify what your A value is, your B value, and your C value. Okay, and this guy's actually going to be factorable, but we're not going to factor it. We're going to use the quadratic formula because that's what we're practicing. And I've got the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2 times A, which is 2. So again, don't forget the way we're finding our A, B, and C, they're the coefficients here. A is 1, B is -4, and C is -12. And that's what we're plugging in. So we're going to go under the house here where most mistakes are made. All right, we've got X equals 4 plus or minus the square root of 16. -4 times 1 is -4. -4 times -12 is +48. All over 2. All right, so now we're going to go under the house, and I get 64, and the square root of 64 is a perfect square. The square root of 64 is the same thing as 8. Now look, some of you guys were leaving your answers like this when it came to completing the square. These are normal numbers, right? If we come over here, this is an integer and a radical. We can't add an integer and a radical. Okay, we're going to talk more about that on our last few weeks together. We'll talk a lot about radicals to help you guys get ready for geometry honors. But here, we have regular numbers. This says 4 plus or minus 8 over 2. So 8 is positive and 8 is negative. So we got to do both cases. All right, let's do the first case. If 8 is positive, 4 plus 8 is 12. 12 divided by 2 is 6. And if 8 is negative, 4 minus 8 is negative 4. Negative 4 divided by 2 is negative 2. So our two solutions are just regular numbers, 6 and negative 2. And notice this guy was factorable, so we would have been able to solve this using factoring and we would have gotten the same solution. This guy was not factorable, factors of negative 8 that add up to be negative 4. And that's why we get radicals in our answers. Okay, that's why it's not factorable. All right, let's keep cruising here. Moving on to number 3, okay? So we notice here it's not equal to 0. I'm going to subtract 6x from both sides. There are no like terms on the left-hand side. So we have 9x squared minus 6x minus 11 equals 0. My A value is 9, my B value is negative 6, and my C value is negative 11. The only thing I see here is that these numbers are getting kind of big, and it's fair to use your Inspire here to help you along, but we'll do that if we need to, and I'll use it when I think that you may want to. So let's see. We got the opposite of B plus or minus the square root of B squared minus 4 times A times C. Oh yeah, you can see how these numbers are growing. All over 2 times A, which is 18. Okay, so we can use our Inspire for under the house. We're going to go under the house here. I have x equals 6 plus or minus the square root, and I'm going to plug everything underneath the square root. That's another way of doing it just to make sure that your calculations are good. I'm putting in 36 minus 4 times 9 times negative 11, and I get 432 over 18. Now, I don't think 432 is a perfect square. We could check it using the calculator by putting it in and hitting enter, and I get 20.78460, blah, blah, blah. It's not, but I do think that the square root of 432 can be broken down further. So I'm going to take my greatest perfect squares, and this is what you'll be doing, and you'll be dividing them into 432. And let's see, we're looking for the greatest one that goes into 432, which is hold on, I think it's pretty big. Yeah, it's 144. So we're going to break this down. We're thinking of this guy, 432, as 144 times 3. So I'm going to take out a 12. So we get x equals 6 plus or minus 12 root 3 all over 18. And now all three of these are divisible by 2. 2 goes into 6 3 times. Actually, 6 goes into all those once, twice, and 3 times. So our final answer is 1 plus or minus 2 root 3 all over 3. Okay, so we have just enough time for one more here. We can see it's not equal to 0. We're going to bring everything over to this side. I do have like terms with my square term. And now I can find my A, my B, and my C. I've got the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Now one of the things that we're going to look at here we get 39 minus 32, 49 minus 32 is 17. You should never get a negative number for now under the radical. Okay, you can't take the square root of a negative number. So if you do, something's wrong. None of that can be reduced, and that is your final answer. So I know that's a lot. I'm giving you 6 problems for these to try. Hey, make sure your quadratic's equal to 0. Make sure you identify A, B, and C. Use your quadratic formula, and we will see how you guys do. Okay? I'll see you soon. Take care. Have a great day. Good luck with the 6 problems.